Okay. Good afternoon. This is six-man session. So if you actually were planning to attend something else, please stay. We have full interesting agenda. So here is Bob. I'm Jen. Ule is with us virtually, waving from far away. So just a reminder, this session is being recorded. So if you're going to say something, it's gonna be recorded forever. This is not well. It's just Tuesday, so I guess you might still need to read it. Just a reminder, please be nice to each other when you're making comments. It's okay to be not necessarily approve the idea, but we need to be nice to the people who are expressing it. So, meeting tips. Before you run to the microphone, please join the Meet Echo using on-site client, using your phone or laptop, and press the button to join the queue. Please do this. It makes my life much easier. Yes, you can find the link to the client in the agenda if you do not see QR code, and I guess you don't, but there is a button in the agenda in the IETF website. It does allow us to manage the queue properly, and we know who is in the queue, and we know your name, but please also state your name when you're saying something. I would appreciate if you put your mobile phones in silent mode to avoid unnecessary soundtracks to the recording. If you're presenting or attending remotely, please mute and turn off your camera until you're actually presenting. Remote presenters probably should use headphones. Yes, we have a chat room. We have minutes. Thank you, Darren, for taking minutes. We have a link to presentations. Agenda. So I'm not going to take more than 10 minutes of your time. And then we're going to discuss source address selection update, SNAC router flag, signaling DHCP prefix delegation availability to clients, and deprecation router alert option, and zone identifiers. You see, we have a lot of working group documents. Great. There is one active individual draft on the agenda, IPv6 node requirements. And if we are all good in following the allocated time, we might have some presentations in the time allows category. Any last minute agenda bashing? No. Good. Document status. Uli, do you want to start with this?
Sure. We haven't published any RFCs over the last two IETFs, but we have three in the RFC editor queue. The segment identifiers draft been there for 98 days, but now in auth 48, so that should be done very soon, I believe, unless Suresh jumps to the mic and says otherwise. Then we have the hop by hop processing draft. That's also in the RFC editor queue, just on its way, as well as the CRH document that I think we started in 2019, or that was the first individual revision. So that's finally now coming out as an experimental RFC. We have nothing then submitted to the ISG, but we have one document that has passed working group last call. It's the extension headers limits from Tom Herbert's, which is gone through a fairly thorough Shepherd's review, and Suresh is now writing, who is the document Shepherd, writing up, doing the write-up, and that should then be ready to be passed to the ISG. Any further comments before we move to the next slide? Then we have two documents in working group last call. It's the source address selection update that has been in last call since February, I believe, beginning of February. And then it's the P flagged one, which has been in last calls since 8th of April, I believe. Both of those are on the agenda today, and let's hope we can make some progress on those. Then we have 3 drafts that we have just adopted. It's a snack router flag on the agenda. It's the deprecate router alert, which is also on the agenda, and the zone UI, which is the third round around this track of trying to get some identifiers in user interfaces. We'll see how that goes. And the last slide, I believe, is your work, Jen. So over to you.
Yes. So last IETF, we noticed that Slack Renum draft is not progressing as fast as we would like it to. And I promised to help with this. And this draft should have been on the agenda, but indeed we missed the deadline. So there is ongoing discussion about how the new revision should look like. And the new revision will be posted soon. And the main issue we're currently discussing is how to avoid the conflict with another draft I have about using subnet-specific link local addresses. So as soon as authors finalize that discussion, you shall expect a new version soon. And I think what we'd like to do to get another round of reviews, another last call, and hopefully, fingers crossed, progress it before the next IETF. I apologize for the unexpected delay with this one. So the last slide from the chairs, it's our regular slide, just to remind you that if you'd like to present in 6-man, some work which is related to other working group, because it's quite natural that sometimes other working group needs 6 men to do something, like give you some bits in the header or create new options or something like that. We fully support that work, but we'd like first to get a confirmation from the another working group that this is a problem worth solving. So we've got a number of requests, which unfortunately we had to decline from the agenda time because the corresponding work in the other working group has not been yet adopted or considered worth solving. So please, before you ask for time here, make sure that other working group, whatever working group needs it, confirmed. It could be an adoption or it could be just a request from the chairs from other working group. So I guess this is all we have to say. Uli, do you have anything to add?
I just wanted to say that we have 3 working groups that we collaborate with. It's SNAC, we have the router flag for that, it's TEAS, and it's IPPM. So we are working with the chairs and the working group in the background and, doing shared last calls and stuff. So that coordination is good, and certainly good if the authors also participate and help out with that. Cool.
Okay, and the first presentation today is update on 6724, so subject selection. Nick, the floor is yours.
All right, I'm Nick Raleigh. I'm going to talk about what Uli said was still in last call, the RFC 6724 update. Go ahead and go to the next slide, please. So if anyone's that's been following this, this has gone through quite an evolution. The original update was to provide a preference for ULA to ULA. There were some concerns over that, rightly so. And so as we've sort of iterated through and worked through these concerns, we came to the conclusion, based on a lot of input from the list, that the idea of known local ULAs made a lot more sense. And so we've gone ahead and worked that into the draft. I think everyone will be pretty happy with what's in there. Basically we take the observed prefixes on a network, and those are flagged as known to be local. We use a number of different mechanisms for figuring out what those, that they are local. Next slide, please. So because of that evolution, we changed the title of the draft to better reflect what it actually is now. We added some heuristics in section 5.3 on how a host maintains its list of known local ULA prefixes to include the address selection, to include in the address selection policy table. This leads to the known local ULA addresses being preferred over GUA to GUA, making them a little bit more useful. GUA to GUA remains preferred over other non-local ULA addresses. Also, ULA to ULA is preferred over IPv4 to IPv4, which helps in migrating to IPv6 only environments in some ways. And we added a bunch of clarifications that were provided, thankfully, from David Farmer and some other folks on the list to improve the text around things like type C hosts when A and B are still out there. Next slide. So open questions that we need answered, I think, before the last call finishes up. And thankfully, Tim was nice enough to put the list consensus as it looked to us in here. Should we treat the FC00/8 differently from FD008? List consensus wasn't really there, but there didn't seem to be a whole lot of really strong views. So we proposed condense that section to refer only to FC007. Is all ULA being preferred over all IPv4 okay? List consensus seemed to be yes. So keep that, the proposal is to keep that precedent. Should we support addition of other off-link known local preferences? The list consensus was so far yes. So we've proposed to include that explicitly in section 5.3. And should we add other additional prefixes and entries for RFC 1918? List sort of was no on that one, so we were going to leave that alone. Didn't feel like it needed to be addressed, really. Next slide. So, final questions. I don't want to use up too much more time. Are the heuristics in section 5.3 good? Open question for the group, for the list. So far, the list looks like yes on that one. There's some text that's been provided by David that you can read here. The proposed text is, regardless of how the PIO flags are set, PIO length 64, and from within FD008, FD00:8 are not already covered in the known local prefix list. They must be added to the list with an assumed prefix length of 48. So the question is, do we do a should or a must? There's a note there that, it sort of details the RIO preferred method that folks can look at. But next slide, please. Those are the questions that we need to get answered for this one. I think we're really, really close. It seems like it's a lot more useful than the original draft was. And so I think if we can get some conversation around those open questions, we can hopefully button this up.
Lorenzo Coliti, can you go back to the slide about open question? No, before that. Yeah. So I have tried to implement this. I actually have implemented something that looks like this. It's not all checked in, but some of it is. I looked at the latest text in the draft, and there's like this 8-point algorithm, which looks pretty complicated. I couldn't honestly tell you if my implementation is compliant with that or not. Nor if I rewrote it, could I tell you if it was compliant. I think that needs to be simplified.
Okay.
What my implementation does, it just looks at all the IP addresses and all the routes, and it just adds implicit 48s, covering 48s for all of them, and that's it. I think that's what the draft says that I should do for FD00, but I'm not sure because it's too complicated. So that would be sort of helpful. Okay. Is this a typo here to only refer to FC00/7? Because FC00 is like undefined, right? Oh, FC00/7, I see. Yeah. Yeah, FC00/8, nobody knows how it works. And I think the risk is that if we write down how it should work, then we're sort of, implementations may grow to like do what we think. And then it'll limit our freedom in the future to define how FC00/8 works. I would sort of, generally speaking, I would just keep the same behavior for everything. But, like you said, there's no consensus. I think it's hard to do anything for FC00/8 because we don't know what it does. But other than that, I do support this. I think it's great. I think it will finally make EULA useful, which is something that we've been struggling with for, 10 years. So that's great.
Thank you.
Can I jump the queue a bit just to answer that? Tim Chan. So should we put FC00/7 in there that would embrace both current EULAs and maybe ULAC or whatever it becomes? Or should we just have the draft say FD00/8 and ignore FC00/8?
Well, you can't do that without changing the draft, because right now the draft says FC and FD behave differently. Right? It says for FC, it should do whatever's on the network, on the wire, and for FD, it should, basically, as far as I can tell, it says for FC, do whatever on the wire, and for FD, kind of cap it at 48. As far as I can tell, that's what it says. But if you want to make it all the same, you need to pick which one.
So Tim Chan again. So the question is, do we just write those heuristics, which have been simplified a bit in the version that we haven't yet put to the list, there's a -10. Do we just define that for FD00/8, or do we still write it with future FC00 in mind, even though it's not used yet? Or do we write FC00/7 and just assume it'll be similar?
Can I make a suggestion? Just treat ULAs the same. If we ever define the other centralized ones, then that can just figure out how this should change. But don't try to do it now. Just treat them the same.
Genlingo, no hats on. Yeah, I totally agree that the algorithm currently looks way complicated exactly for differences between two types of ULAs. Actually, I was going to suggest, yes, let's just treat the whole /7 the same way. But now I'm thinking we are not supposed to use FC, right?
Yep.
So maybe we do not need to say anything. They should be just depraved, not used, and just completely ignored. Maybe it would motivate people to do the right thing and use FD. Like, I don't have strong preference, but we definitely should not be treating them like have separate rules. We either have /8 or 1/7.
Just wanted to clarify how that came about. FD, there was some robust discussion about that. And there was a compromise where, there were certain participants who were like very convinced that FD should be /48. And people said, well, okay, but for FC, which we haven't defined yet, we should be more flexible. So that's why the complexity came about.
Yeah, so Krishnan, I was going to say pretty much what Jen said. Somehow she read my mind, like she read my Pecha Kucha as well somehow. But anyway, but I think the point is, like, we don't know how FC00/8 is going to be used. So I think we should not make any presumption about it. Like, like Bob said, like, let it decide when it comes up, like, how we deal with it, like, and where you put it in the preference table. So I would just say, like, stick to FD00/8 and don't special case the FC008 at all. Like, except it's not supposed to be used, but we may not need to deal with it because, like, we don't know how it's getting used, if it's getting used.
Eric Klein, no hats. I wanted to see if it was helpful to draw a distinction between policies derived from specifications, where you like infer /48 because that's what the spec says, versus policies that you apply that you have learned through control plane information, like PAOs and RIOs. I think it would be fair to treat all ULAs, if you learn it in an RIO, you could treat it as local. The network is telling you that. Since the specs aren't written, I don't think you could rely on any information that might get changed by a specification later, if you see what I mean. I think there's a conceptual difference between those two things.
I think I have something useful to say, actually. It occurs to me that it occurs to me that like my implementation needs to do something, right? But it occurs to me that if we basically stay silent on FC00/8, we are sort of implicitly giving it the other label, which will match nothing. So if I get, so the other thing is, like, if I get an RA, if somebody numbers my implementation in in FC00/8, which it can do, right? Like, I'll get an RA, I'll get an RA on a PAO. I'll get the legacy behavior, which is what we're trying to avoid here, right? So we are trying to make ULA more useful, but if we don't apply our new known local insertion to FC00/8, then that is still using the legacy bad behavior, which we don't want. Also, you have to figure out what happens when some of it is FD00. Is that the same as FC00123445? If I've got an FD00 address, I don't know. So I think we do need to think about that a little bit more in detail. to be honest, my preference would be to say the same rules everywhere. I was on one side of the debate, and I observed that 4193 does say 48, and that's how it should be. And if we go with that, then we can apply the same rules everywhere. I think that's better, to be honest.
My understanding, or my recollection rather, I should say, from 4193 is the difference between ULA C and D is allocation policy, not a prefix boundary or anything like that. So that's fair. Yeah, that makes sense.
Okay, so I guess we shall expect an updated revision.
Yes.
Thank you, Tim. Tim, run into the mic.
Sorry, Tim Chan again. So go back, no, forward a slide. No,
Forward.
that one, yeah, thank you. So does the room have any comment here? I mean, the original list discussion was that RIOs are the preferred method for deriving what we're adding here. And therefore, for RIOs, we say must, and for POs, we say should. But from what Lorenzo just said, and he's obviously about to say it again, we should just have the same for both. And I think you've, in your implementation, you've sort of done you've done it, whether you consider it from a must or a should.
I think from an implementation perspective, it's also moderately difficult to look at RIOs and PIOs. You have to sort of either do, so on Linux, you have to either listen for RTM new root, RTM sort of, looking at roots and IP addresses is data that you have to have anyway in the stack, so it's a lot easier to implement it that way. That's why I did it that way. My code doesn't actually look for RIOs or PIOs. It just says, here's the addresses I have. I think that's actually, easier to implement and use and more useful. This distinction between should and must, I don't have an opinion because I don't understand it. It seems too complicated.
Okay.
Okay, I think no more comments. So thank you, Nick.
All right. Thanks for the input. Great. Thank you.
Okay, and then now, Ted, I guess you next. Ted, wake up.
Okay, so this is just a quick update on the snack router RA flag draft, which is extremely complicated and long and will take you at least 2 minutes to read. Quick summary for anybody who is not aware of this: snack routers are self-configuring routers. They join stub networks to existing infrastructure automatically without any sort of operator intervention other than just plugging it in. We currently have one use case for this, which is thread border routers. So this is an IoT router that connects us to an 802.15.4 mesh doing 6LoWPAN. In order to make that work, these are disparate media, so we can't have them just bridge together. So we had to actually do IPv6 routing. We couldn't do it with IPv4 because NATs are not bidirectional. And so, yay, a use case for IPv6 that cannot be in any way solved with v4. So that's what we have. And the trick here is that in order to make this work, we need to be able to tell the difference between advertisements, router advertisements that are sent by these snack routers and router advertisements sent by infrastructure, so that we can prefer just the infrastructure stuff rather than publishing stuff from our snack router if it's not needed. Next slide. So the document's been adopted. There's a -01 actually, I think now, that had some updates from some IANA comments. We've asked for early allocation of the flag bit. The reason for doing that is the use case for this flag bit is very stable at this point, and we actually have deployed implementations that are just like randomly picking a flag bit, and that seems bad. So it would be really good to fix that sooner rather than later. Like I said, there's been discussion about using this bit or a second stub router bit on the stub network side, but the use of this particular bit on the infrastructure network side is very stable, and we don't envision it changing at all. So I don't think there's any reason not to allocate the flag now. So basically the question is, A, can we have the flag bit? And B, does anybody have anything that they think needs to be done to this document before we go to last call? And C, if not, let's go to last call.
Lorenzo Caliri, I was able to read the document. since you started. But I noticed though that it says a stub router that is not explicitly configured as part of the network infrastructure must set it to 1. Good.
Yeah.
It doesn't say who or what must set it to 0. Presumably, an infrastructure router must set it to 0. Maybe we should say that.
That's a good point, and I think I agree with you. Yeah. So please send a diff or a pull request or a
Other
comment.
than that, yeah, working group last call sounds good.
Cool. Thanks.
David, are you online?
I think you need to add interactions with RA guard and other things like that.
So we actually have an appendix in the snack document that talks about that. I don't think it's appropriate to talk about it here because it's just not, this is just defining a bit. It's not defining a protocol specification. So if you really want to understand the way that the protocol works, you really need to read the snack simple document.
I would agree with you on that. However, even just noting that there could be interactions would be worth noting, I think. But
I mean, if you can articulate an interaction that you think should be noted, I would be happy to add that, or Jonathan would be happy to add that, but I can't think of one off the top of my head. I mean, it's an RA. If you have RA guard turned on, it's going to get filtered. So it doesn't matter what bits are in the flags.
exactly.
Yeah.
I want to echo Tim Winters, sorry, QA Cafe. I want to echo what Lorenzo said. You should definitely tell people if you want them to turn it off, when to turn it off by default. And then the other thing, I couldn't find anything in the snack text, and maybe this is a snack comment more than anything, of what to do when there's conflict.
What do you mean by conflict?
2 routers giving out different flags, what someone should do with that on a network.
The flag is specific to the router. It's identifying whether or not the router is a snack router. So there shouldn't be,
Right.
It doesn't even make sense to compare 2 different RAs to see which one is which.
I meant flapping as in the router was changing being a snack router or not. Does that not happen? It's either the bit is always set or it's never set.
I think it might be good to point out that's a thing to think about, but certainly we normally we don't expect a snack router to ever not be a snack router. Well, I shouldn't say that. You could have something that can be a snack router, it could also be manually configured. If it were manually configured, it would certainly make sense not to set the bit.
Okay, so that answers my question. The answer is we should just tell people when not to send the bit and when to, and that you don't expect conflicts, I think would be the general thing there.
Yeah.
Diesel, another corner case. What happens if a router is a snack router and the infrastructure router at the same time? So for example, you have a CPE was a radio for ZigBee.
So I think you're talking about something like maybe an Eero, which has a thread radio in it and is also a Wi-Fi router. And in that case, I would argue that's not a snack router. That's just an infrastructure router that happens to have a thread interface. Now, that doesn't mean that that's exactly what they're implementing, but that's my claim.
I think this should be added to the specification.
Yeah, I think we had a big discussion about that in one of the interim meetings, but I think we added text, or at least we have a pull or an issue open for that.
David Lamparter. I do think David Farmer's comment about RA guard and stuff like that makes sense. I also think you answered it on stage, and you should just add that to the draft and be done.
Add what?
The text you said on stage, RA guard is not going to care about it, and that's it.
Okay, fair.
Suresh Krishnan also talking to like David's point. Part of it is like my fault that like this thing got split out on button 6-man, because like I was in Snack and I saw this and I say like maybe like telling 6-man what they're doing with it is not like they don't have to read the whole Snack spec to understand what they're doing with it. So if somebody wants to read more, they should go read the Snack spec, but at least tell them about the use of this bit, right? Like,
right.
So as the instigator of that, I think what Ted is doing is the right thing to do. Like, if you need more details, the Snack document needs to take care of it.
Right.
But 6-man is like really about like, hey, is using the bit the right thing to do? And I think it is, right? And I think that's what 6-man is deciding on. So I'd like to keep that discussion here. And then the substandard discussion in Snack. Thanks.
Yeah, I mean, one way to put that would be basically if you are not intending to read the Snack simple document, then you must set the bit to 0. Yep. Nope. That was a great comment. Thank you, Lorenzo. Yep. Thanks.
Philip, are you still in the queue, or you just forgot to? Okay. So, okay, thank you, Ted. I guess we know what the next step should be, so thank you. Lorenzo, you're up next.
No, okay. Voice operated clicker. Is it some AI thing that? Okay, so we have actually renamed this draft. There was a lot of confusion, and I admit, as an author, only having understood some of it like fairly recently. So I think that is hopefully reflected in the better reflected in the text. Next slide, so that you'll see that the title is different. So what is the goal of this work? This is partly a recap, but we have learned some of the details thanks to recent discussion. So the goal was always, and now remains, to signal that the network supports the PD per device addressing model, which is an addressing model which will soon be published by the IETF as an RFC. It's in the RFC editor queue. And so this is sort of kind of a baked model that the IETF has documented. And just like we have the A flag for SLAC and the M flag for DHPV6, we have a flag that signals this. Why do we need a flag? The most important reason we need a flag is that if a device implements this model on the device side and it turns it on, it will ask for a prefix that is SLAC sized, because that's what the PD per device draft says. And on many networks, such as home networks, it will get one. And that'll all work as intended. The problem is if there are too many devices that ask for these prefixes and get them, the network will run out of space. If you have a /60 at home, you've got 16 devices, 16 phones ask for prefixes, your network is now out of space, right? So this is why this is why a flag is needed. There are other reasons why it might be nice to have a flag, like say, oh, try PD or don't try it, but those are secondary. This is the reason why we need it. And again, why SLAC size prefix? Because that's what the model says, the model that we have published as an RFC, or will be. Right? Okay, next slide. There's been after last call, there's been a sort of fairly lively discussion that, as I said, that the operational model draft is in the RFC editor queue. We've had a last call, it was quiet for a while, and then there was a bunch of discussion more recently. We think as authors that the discussion mostly focused on the deployment model, not the protocol. And so that discussion kind of should have happened, did happen actually partly on the discussion of the V6 ops draft, which is now in the RFC editor queue, but that some of that got repeated here, which is fine. We didn't really change anything in the protocol specification. The diff is not very big. So next slide. Here are some of the issues that were discussed. Some folks felt that it should be possible to use arbitrary prefix length. And basically the question was, why can't we say that P means that PD is available, but you could get a 127, a 96, an 84, you could get whatever, right? So we clarified the text and we renamed the draft to make it very clear that this is signaling PD per device. Why? Okay, so the reasons for this are, if you want to use a model that has longer prefixes, 80, 96, 128, you don't have to have any signaling. The device can just ask for it and it can get it, because you're not going to run out of space on existing networks, right? This is one of the problems we're trying to solve here. Home networks, you ask for 64 because that's what PD device per device says. You get it and then you burn down the network, right? So if you do this with an 80 or 96, doesn't matter, right? And you can't really rely on a DHPV6 server to know if you're a PD per device because it's not written in your DHCP request, right? It's like you don't know if the client needs a 64. Like if I plug in a home gateway, that needs a 64 because that's what 7084 says. If I'm an Android device that has a PD per device implementation, I don't need a 64. I could use a 64. I could use Slack. Doesn't really matter too much, right? So I think that's why. And so even if you say, well, the device should just ask for a prefix, and then the server would say 64 is too big, I don't have one, no prefix avail to you. In that case, that'll slow down provisioning. And then like one of the goals again was to make sure that PD per device is deployable and works well. And I think that would be sort of making it slow like this is not a good outcome. So this is why the text is the way it is. Next slide. There was other questions like, can we signal other PD use cases? We don't really know what they are at the moment. There was one that was suggested to be using tethering. We sort of like, there seems to be consensus that this is out of scope, right? It's left for future work. Again, deployment models that use longer prefixes don't need to be signaled. And you could argue that you want to signal tethering, but there's consensus that should be done in a separate document. So that this one is sort of resolved, I think. Next slide. There's a concern about prefix exhaustion. We don't really think as authors that this is, and there was also support on the list for that point of view. The observation is people run IPv4 networks. IPv4 networks run out of space if you don't give them enough of space. People know how to solve this problem. And yes, it is obviously different from Slack or DHCP6 INA, which can't run out of space, but this is not something that's insurmountable. It's inherent to the deployment model, and we think there's a good trade-off here, right? Because and also some folks observed that actually planning for 64s is easier because IPv6 has more bits to subnet. Next flag. Also, the P flag should be 0 by default in the document. There's a concern about address of address space. That was a concern that was raised during the ops draft discussion. Yes, this is not for everyone, and that's the reason why we need a flag. You can't run this on home networks today. But it is acceptable because many networks do use 64 per device. All your mobile phones have 64s, right? And this is not an earth-shattering development. It's been the case since we deployed IPv6 on mobile. And also, we actually do think that there is enough space for this. It's true that not all environments will have space, but that the amount of total space, if you actually can request space, it's actually not excessive. Next slide. Oh, and there was another question. I was like, why are we creating a new addressing model? Well, that's kind of a question for v6 ops. Why did we create it? But I mean, I think there does seem to be rough consensus that this model does make sense in some places, right? And as for why we burn a flag for this, well, both of the current addressing models that we have, which is DHCP6 and Slack, they do have flags. And this model is an operational model which will be published by the IETF, and it actually has meaningful advantages in terms of scaling and in terms of ability to form as many addresses as you like while still giving the operator the benefits of tracking and forensics and accountability. And we think this is actually a really important bargain that we are kind of trying to strike between the folks who want Slack to be able to create infinite addresses and people who want accountability. So this is actually really important. We think this is important for the ecosystem. All right, I think that's kind of it. Yeah, so like I said, we haven't made a lot of changes. There's been a lot of discussions. We have tried to clarify it, but I think hopefully we sort of are in a better place as a community. We sort of have a better feeling about this document in general, and maybe we can close the last call and request an early allocation or otherwise move forward. Yep. Questions?
Shiraz?
Hey, thanks, Lorenzo. So I just noticed one thing. I don't know if you wanted to address this or not, but I'll just throw this up, right? So one of the things is to kind of show that like you have Slackable prefixes to hand out, right? Is there some kind of runtime checking on this? Like, is the router going to turn it off or not? I'm just throwing this up, so just think about it. I don't want an answer because I don't have a good answer for it, right? So like, because one of the goals was to have the client not try and get no addresses available, right, from there. So will this turn this off? And if it does turn it off, will the DHCP state machine keep going for the addresses to renew them, right? Just think about this and write something over it because I think it deserves to be said. It's not the draft. I just checked the latest version. Thanks.
It might be possible when the router is the DHCP server, but when it's a centralized server, can't really do that. Yeah, but we could say the router may,
Hi, Lorenzo. Tom Hill from BT. We've had some conversations about this in the past, and we had a really good debate about it. And I've kind of been thinking about it on and off ever since. the suggestion here that we use a flag, albeit they are valuable, to make this optional, configurable in a fashion so that it's not a sort of a static rule, I think solves most of the concerns that I had about kind of turning IPv6 into a 64-bit protocol. So on that, really happy. That sounds good. The other thing that I would note, I think just for everyone thinking about this, is the alternative to this is a lot more NAT66 or MPT, and I really don't want to go there.
That's the plan, right? That's really what we are trying to go for partly, yeah. Thank you.
Eric Klein, AD hat on, I think. Clarifying that this is a flag just to indicate that the PD per device model is in effect, or is available rather. I think that's very clarifying. And it means that if we want to start doing funky changes to that model has to get updated, not this flag. And if we want to change that, you have to convince the v6 ops AD to go yank it back from the RFC editor. But anyway, so thank you very much for that clarification.
Thank you.
Nick Braulio, ESNet. I don't have a whole lot to add. I just want to say thanks for this. This is sort of finishes up some of the prefix per host stuff that will solve some operational problems that I have personally had to deal with. So thanks for your work, and I support it.
Thank you. Is Tim in the queue?
Tim?
Hi,
If Tim's not there, I'll go on.
Sorry, Tim Chan. So,
yeah, Tim is next.
Yeah. So you said about using flags. How many flags from the initial specification do we have left? I think there's just two, and this and presumably the snack flag will use.
No, the snack flag is in the array.
Oh, okay.
And that one did get exhausted, but we have a flags option, or we have a like extra flags option, I think, right? Is that right?
Yes.
Yeah. Right. So the array flags did get exhausted, and we have an option for future flags.
Well,
the PIO flag.
So then there's actually two left, and then there's the whole extension field.
Yeah.
Okay.
And if you look at the text in this draft, you'll see that the current PIO flags are LARP after this one.
Oh, yeah.
P being the last one. The LARP has 4 letters, so there's under 4 left.
Okay. All right. Thank you.
Owen?
So I don't know what to say here that wouldn't repeat some of the stuff I've said on the mailing list. So I'm quite in favor of the idea, and I'm very much in favor of us solving the network extensions problem. I think this draft leaves too many of the corner cases unresolved, and that some of those are easy fixes, and I think we should do those. But one thing that is definitely clear to me is that we cannot reserve network extensions only to large enterprises, which this seems to propose. So one solution to that is that, of course, that the PD or the P flag only applies to the ND cache problem, and we solve the network extensions problem elsewhere. To Eric Klein's comment, I mean, this sort of is yet another argument that we shouldn't split work across multiple working groups, because we're kind of held hostage now to decisions done in a different working group. But that's clearly something we have to feed back to the ISG. As an example, I don't think I should. I don't know quite, and that's probably something we should discuss in this working group, what the best resolution is to the issues. I think I have about 6 listed here, and it's we don't have time to go through all of them. But just as an example of having the P flag in a PIO, which is great for the ND cache problem where you have a hybrid link of Slack and P flag capable nodes. What you do after all those nodes have transitioned and are PD capable, then you probably wouldn't send a PIO and have an on-link prefix at all. And then you suddenly have no way of signaling that you want to do PD per device. So there's a set of all these corner cases that haven't been resolved. I'm happy to provide some text, and then we can do a beauty contest or something. But But at least I think we need to solve all of those corner cases. And there's about 6 of them I think I have on my list.
Okay, so I'm not, obviously not Eric, but I think to your point around, this is why we shouldn't split work between working groups, this was not an exercise that was carried out in secret in a different working group working at cross purposes, right? You yourself posted these comments in IETF last call and they were considered, right? So I think it's not necessarily, and I think, it's not that so that wasn't sort of an intentional sort of, as for the corner cases, I mean, I think we can continue to discuss that. I don't know what the best way forward is here. I think we sort of, the operational model is actually fairly clear, I think. And the discussion around network extension, we can definitely work on a network extension that is not using /64. I personally don't believe it exists because the only 2 models are 64 or 128 with NAT. And the reason for that is as soon as any client accepts a different length than 64, then that is the length that the network will assign. And after that, you just end up in a race to the bottom. And that concern has been stated several times, not just by me on the 6-man mailing list. It was stated when we did the original V6 op docs, and that's why it resulted like that. So I'm not sure really it's sort of more of a question for the chairs and AD what we should do here. I mean, I think personally, as an author, I find it very hard to put a finger on these concerns, or the exact concerns here. We have tried to engage in discussion, but I feel that sort of there's like this vague and amorphous concern from Willie that is really hard to sort of address technically, and I don't really know what to do about it, to be honest.
I don't think that's quite fair if I'm allowed to reply to that. It's simple. If you don't have a PIO, you have no place to set this P flag, right? There is gaps around on-link protocols, for example. How would MDNS do? Should it advertise these prefixes that are no longer on-link?
I replied to that. I'm sorry to interrupt you, but I replied to that on the list, and you didn't. And you did not contest that reply. Please don't raise that again, right? I mean, if you want to point out documented corner cases, they have to be unresolved.
Yes, they are unresolved. Are they in the document? I mean, that's the problem we're at, right? So, and we could set a few questions, a list of questions to the working group and see where the room is on some of these. We might, we could do a side meet. We probably don't have all those questions ready to go in this session. We could do an interim. I mean, we could, find some way of get this resolved and worked out, right?
As an author,
So
I would.
I'm going to actually sort of call time, but I think we need to hear from Eric, and then I had a few things to say, and then we'll move on. Eric?
I think it's perfectly fair that we should consider corner cases in the signaling of PD per devices available. And when all devices on a network are PD per device capable, what do you do? And if that's put a dummy PIO in of some kind, you should just document that. We should get objections and concerns out as fast as possible so we can address them. And we should not let the perfect be the enemy of the good, I think.
Suresh?
Bob, did you want to go before me? I just had a suggestion. Okay, so my suggestion would be like, Ulla, if you can just throw all your issues as separate things into an issue tracker, the chairs can then track it and see the resolutions. Lorenzo can put in the comments like what it happens, and then we have a record instead of going through like a bunch of things together. Like we can have like individual things listed and keep track of them.
They're already on the 6-man tracker list.
Okay, so I think we're going to move on. I mean, my take from reading the list is I think we're very close to having consensus to advance this. We should see what these issues are and see if they've been discussed before. But I will look and we'll see what happens next. Thank you.
Ron, are you online? Okay.
Hi, folks. Can you hear me?
Yes, we can.
Okay, I'll try to go fast and make up some time. The proposal is to deprecate the IPv6 router alert option. Next slide. Now, what do we mean by that? We deprecate the option. Protocols, excuse me, protocols that do use the router alert option now may continue to do so, even in future versions. We hope that they don't in future versions, but they may. Future protocols must not use the router alert option. Next slide. Next slide. So what's the motivation? Well, we want to motivate towards an architecture in which HBH options will be processed on the forwarding plane. We want to reduce HBH access to the control plane. This will reduce operator motivation to discard all packets containing HBH options, which is what many operators do today. Next slide. So the question is, if we deprecate the router alert option, do we have other means to do what it does today? Do we have alternatives to the router alert option? What I'm going to do is show the two use cases for router alert. One is RSVPTE, the other is MLD, and I'll demonstrate that there are other options. Next slide. Okay, the RSVPTE use case. We send a PDU from an MPLS ingress node to an MPLS egress node. We want to cause every node along the delivery path to process the message. How can we do this without router alert? Next slide. Okay, here's the alternative. The ingress node encodes the MPLS egress node's address in the message body. Then the ingress node sends the message to the first node along the delivery path. The first node processes the message. It sends another message addressed to the next node along the delivery path. Repeat until you get to the endpoint. This solution is widely deployed. Most RSVPTE implementations these days used to use the IPv4 router alert. They don't anymore. As far as I know, there are no IPv6 RSVPTE implementations. Next slide. Now, let's talk about the MLD v2 use case. In this case, you want to send an MLD v2 message addressed to an IPv6 multicast address. And you want to cause every router on the segment to examine and process the message, even if it has no interest in that multicast address. So how can we do this without the router alert? Next slide. Well, same trick. You encode the multicast address in the PDU, in the MLD v2 message. You send the message to a well-known IPv6 multicast address. It would be a new one, like all MLD v2 routers. Now, this solution isn't standardized, implemented, or deployed anyplace. I include it just to show that it is possible and it could be done. Next slide. So what am I asking for? This is basically a thumbs up, thumbs down decision, a yes, no decision. So I'd like to ask for a working group last call to get some finality on the list. Do we want to do this or not? And that's it.
David Lamparter. There is a class of devices missing from the draft that needs to be mentioned, which is multicast snooping switches on the way along who process MLD. I think that it's worth mentioning that they are also affected by the disappearance of RA at some point.
Could the same solution be used to address them?
Yes, absolutely. It just needs to be pointed out.
Okay, I can do that. I can update the draft.
Eric Wenk, and by the way, Ron, nice to see you healthy there. That's pretty cool. I just want to know that when you say existing use of router alert may continue, and then you give example how to bypass the existing use. I fail to understand the logic. Was it just example?
Yes, it's just an example. I'm not telling the PIM working group that they must do this. I'm just demonstrating that there is an alternative.
Understood, thank you.
Tim Chown, I agree with the sort of the high-level spirit of what you're doing here. I think the wording in the, especially the abstract and bits of the document is a bit confusing though. You say deprecated and then, oh, well, you can continue using it, except for future definitions. So maybe think about how that's phrased to make it less odd.
I do note that that's exactly what, when we say deprecate in most documents, what it means.
Oh, really? Okay.
Yes, if you, like when we deprecated site local, we didn't say everyone using it today had to stop. We said no one should do it in the future. So that's the typical use of deprecate.
Okay. Well, I remember in MDOD, the most recent one I was involved in was MBOD with deprecating the use of interdomain multicast other than ASM, and that was stop doing it. So there's obviously different interpretations, but I will obviously believe yours over what I interpreted. Thank you.
Thanks. Thanks, Ron. Thanks for writing this. And one comment I had, this is from like an older job, right? I was working on some chips that used the router alert as the only path to shunt something to the slow path, right? This was the only mechanism that would do it. So I'm just wondering if you probably should talk to some silicon vendors, like especially who have legacy silicon, to see if this is going to harm some of their like extensibility plans, right? Because like if that's the only path to go to the slow path, what does it leave them with, right, for the future, right? Like that's something I would like to explore. Like, you know, I'm not saying like this is a bad thing, but I would at least try to do an outreach to somebody, like, you know, somebody at Broadcom or something, to see what they feel about it, right? Like, you know, how, does it close off some extensibility path for them? That's it.
Fair enough. Let's meet offline and you can give me some references, some contacts.
Perfect. Thank you.
So the other question I would like to hear from the working group on the list is, do we want to go ahead and deprecate router alert, which sort of means don't use it for anything new, but do we want to do that without, it seems like MLD is the main IPv6 use for router alert, and do we want to do the deprecation before we have some alternative, at least in under progress, you know, a draft that says, here's how to do MLD without router alert, or something like that. So that's a question that we'd like to hear from the list, on the list about this. Thank you.
Thanks much.
Eric, do you want to repeat your comment on the mic?
I'm going to regret saying it without having enough information, but I think there's a 3810 bis document on the telechat for August 8th. That's MLDV2 bis. So I haven't read it, don't know what's in it. Just observing that it exists.
Yeah. Okay, Brian, the floor is yours. Just tell me, I'll move the slide unless you want to control them yourself.
Okay, can you hear me?
Yes, we can.
Okay, good. So the title slide speaks for itself. This is a draft that we adopted in the working group quite recently. Next slide, please. So what we thought we'd do first is remind you why we're doing this, which was because we failed to modify the syntax of URIs to support linked local addresses. And just if anybody doesn't know, we failed because there were two IESG discussers that couldn't be resolved. And in particular, the concerns from the web community and the browser community about parsing and what's called in their lingo cross-origin security remained after a year, 6 updates to the draft, and no sign of any compromise solution being available. So we switched our focus to focus on the user interface rather than the wire format, since the URI is basically a wire format. So next slide, please. And we presented this draft in some detail the last meeting, so this is really the only technical slide we have. A reminder of the main content, which says that a user interface that supports the entry of an IPv6 address should provide a means for entering a linked local address, which is qualified with a zone identifier, which most people know as an interface identifier. So ideally, it will simply support the format defined in RFC 4007. If that isn't practical for some reason, because you don't like percent signs, for example, you could use an alternative delimiter where a very old discussion suggested the hyphen as the best compromise. And if even that is impractical, you could have 2 separate input fields, the linked local address in one box and the interface identifier in another box. And remember, the whole idea here is that users shouldn't have to actually type in IPv6 addresses. If this use case arises, it should be one where you cut and paste, because you get the IP address from some other source. In the really worst case, you type it in, but let's hope that would never happen. Next slide, please. So during the adoption call of the draft, which is basically a lot of wrapping text around that detailed technical proposal, we had to make one change for the adoption call to succeed. There's a sentence in there that says the proposal does not resolve the difficulties in considering the zone identifier as part of the HTTP origin model, which is a recognition of the fact that we failed to find something that was acceptable to the web community and the browser community. The compromise text that was added to that during the adoption call was a very blunt statement. The recommendations and normative statements in this document do not apply to web browsers. In other words, the web browser community is not willing to solve this problem and doesn't think we have a solution to that problem. And there's no way to disguise that. That is their position, and they're sticking to it. So the next slide. The only open issue that the authors are currently aware of is a relatively minor one, which is the specification in effect extends RFC 4007, which is the RFC that is originally created the idea of zones and zone IDs, which are normally implemented as interface IDs. It doesn't change anything in that RFC as far as we can see. It doesn't require any changes in the IPv6 stack because it's only a user interface question. So the author's opinion at the moment is that this is not a formal update to RFC 4007. Now, it isn't in the slides or in the draft itself, but there are a lot of reasons we might want to reopen RFC 4007. It's quite an old document. It's got some obvious defects, but we think that's actually orthogonal to this current draft. So really, that's it. That's all I had to say. Bob Hinden is the co-author, so he can step out of his chair to join the conversation as he wishes. And the next slide, please, is the last slide.
What? No one in the queue? Bill.
Hi, Bill Fenner, Arista Networks. I know this is a hard problem. You know, I tried to solve it, 16 years ago and failed. Is there any point to doing this if it doesn't apply to web browsers?
There are use cases in the in the document, which I didn't go through this time, which we did go through last time. Well, my favorite one is there's no way to put a display filter into Wireshark specifying the interface identifier. So you capture a lot of stuff with Wireshark and you want to focus on things that had that interface identifier, and there's no way to do it. There's little use cases like that all over the place. And I also want this personally to be on record, because it is a message to the browser community. You need to fix this, that they have some very deep problems in handling linked local addresses, RFC 1918 addresses, ULAs, and .local DNS names, all of which drive a wedge through the middle of their security model. So I think this is just a small side issue for the web browser. In fact, when they solve their main issue, they should be able to look at our RFC and say, oh, yes, we can do that now.
Okay, thanks, Brian.
So speaking as a co-author here, it would be good if we could figure out some way to send that message to the web browser community. I don't know if it should be in this document or there's some other path, but we at least I think, or the co-authors think, it's important that web browsers be able to do it. How they do it, they should figure that out. Eric?
Yeah, there's a comment in the chat actually from Christian Amsus, says that this applies to the IoT world, where co-op frequently deals with IP literals with zone IDs without being bound to the browser world. So I think there are going to be use cases all around.
Do you think the document's ready to send to various well-known web personalities?
I don't think they will take much notice of it because it says you're exempt. So yeah, sure, we could do that. I mean, as I said, the only open issue we got is this relatively small issue of whether it formally extends 4007. So my personal feeling is, it says ready for working group last call as it's ever going to be, but maybe I'm pushing ahead too fast there.
Well, I wouldn't underestimate the amount of umbrage that could be taken at just about anything. But I think if it's ready for last call, then I can help see that it gets sent to certain well-known folks. And as far as updates is concerned, updates is very ill-defined, underspecified, I guess is a better phrase. As long as it doesn't obsoletes 4007, which I gather that it does not, you can just leave updates off for now. And if somebody in the telechat at the ISG says you should do it, then we add it at that point.
Yeah, I can't remember at the moment who it was who said maybe it's an update. It might possibly have been David Farmer, who I believe is online. That I gave the author's opinion, but other opinions may differ. Thanks.
Lorenzo Colletti. So do you, I mean, on one hand, I'm not even sure this is necessary, right? Isn't that like syntax part of the textual representation of IPv6 addresses already?
Not really. It's sort of a bit strange because it got added, sometime after the normal textual format was defined. I'm pretty sure it's not in the one that told us to lowercase all IPv6 addresses. I can't really remember the number, but I think if it was in there, we'd have referred to it in the text already. So I think it isn't. I think it's quite disjoint. It just crops up in 4007.
Right. So I guess the other question is like, if 4007 says that IPv6 addresses written down in text must always have the interface identifier, then what is this document really?
It doesn't say that. It doesn't say that. It just says this is how you do it.
Okay.
It just says, the way you do it is this. It doesn't say you have to do it.
Okay, but if an IP address that's link local has to have a scope ID on it, because otherwise it's meaningless, and I want to enter an IP address into a program, then it's already sort of required that it have the zone ID on it.
It's pretty much inquired, but you know, if we want to make a point for the wider community, we can publish this. If you decide, well, we're just going to ignore this problem and think it'll go away one of these days, then we do nothing.
I mean, it's yeah.
Didn't we have this discussion during the adoption call? I think we did.
Well, I mean, it's not too late. It's never too late to pull the plug, I suppose. But no, it's yeah. I mean, I think the browser manufacturers have already made their decision, right? So if we're sort of gonna say, oh yeah, we're gonna publish something, and you're gonna learn from that, no, they won't. But on the other hand, I think tools probably already do this.
Well, as I said, some of them don't. You know, there's a list. There's a list in the in the actual draft, which I don't have in my brain, of use cases.
Yeah, to be honest, the Wireshark use case is, I think, more correct than what we propose here. But okay. Anyway, I don't strongly oppose. I just don't think it's necessarily very useful. But
is there any difference between a web browser and any other app that takes a v6 address in the UI and emits HTTP?
Well, the difference is that internally inside your software, you need to represent an IPv6 address as two items, actually. I mean, properly written IPv6 software has to always treat the address as two items. The 128 bits of the address plus the zone identifier, right?
I guess I'm asking is the
And
notion
a
of
lot of browsers don't do that.
is the notion of a web browser well defined, or is it the people who object know who they are?
I don't think this is a right working group to get an answer to that question, honestly. You know, because there are lots of programs that handle URIs that are not browsers, right? And some of them do this right. You know, when I patched wget to do this right, it turned out to be 2 lines of C code because they do everything else right. They carry addresses around as addresses plus zone identifiers, right? Which is basically what you have to do. So if your code that interprets an IPv6 address, whether it is their URI or otherwise, has the right model internally, then this is trivial. If your code doesn't do that right, if it thinks that IPv6 address is just 128 bits and nothing else, then your code won't work. It's a strange thing, but there's a lot of code around that doesn't recognize this problem.
Okay, David, you're next in the queue.
Yeah, can you hear me?
Yep.
Yes, we can.
Yeah, thank you. So first off, I'm fine with punting to the IESG whether it should be an update or not. That's what they're there for. They can decide that. The other thing is, it is not a fact that link local addresses have to have an interface identifier. The specification does not say that. It says if you want to include one, this is how you do it. And in fact, if you build the correct default zone stuff, you don't need zone identifiers. I have a different solution to this problem, and that is fix zone identifiers. But I don't oppose this solution either. It will at least provide some guidance to some applications that have ignored this problem.
Yeah, you're completely right, of course, that if the default zone thing is done properly, then you can manage without specifying it until you hit a case where you can't, if it actually matters, if you have two interfaces active on your machine. And it may matter. right? But you're completely correct if the default is implemented properly, which it isn't on a lot of systems. But that's one of the reasons I think 4007 needs a new look, because we need to find out where it's being misinterpreted and do something about that.
Okay, so we're just on time. No one else in the queue. So thank you very much, Brian.
Okay, you're welcome.
Okay, Tim, you're next.
All right, hello. So I'm here to talk about a proposed update or revision of RFC 8504, the IPv6 node requirements. This is something that myself, John, and Tim, as authors of 8502, all three of us are happy to work on. Once we've discussed this, and if there's agreement to proceed, maybe we can take on extra authors, but that's where we are at the moment. All three of the original authors are happy to do this. Next slide, please. So the no requirements draft, RFC, is quite widely cited. It's formally a BCP, and it captures a wide range of IPv6 requirements for nodes. And it's quite widely, if you look, it's actually also quite widely cited by other documents and RFCs, etc. We've had two previous versions to 8504, and you can see there 2006, 2011, 2019. So it kind of feels like it's about time for a new version, an update. There have obviously been many V6-related RFCs published in the last 5 years, and there are also some very interesting drafts in progress at the moment as well that we might want to reflect in this document, and that might become RFCs by the time this becomes an RFC if we do go ahead with it. Also, I think a couple of meetings ago, one or more of the chairs did indicate that they would welcome some work on this. Next slide. So yes, we're going to need your input to make this happen. Obviously, the three of us could hack away at it, but some steer would be very, very useful. So what we've done is posted an initial 00. That is essentially 8504 as it was, but with, I think there's like half a dozen small edits, just very minor changes for things that are clearly obsolete or need to be changed and updated, non-semantic changes, one might say. So what would we do to do this revision? There's obviously addition of text related to all the new RFCs that have been published since 8504 was published. There may also be some changes in requirement levels that have happened with other documents that have been published, or the way thinking has changed around may, should, and must on various things. There's some things also that will now be obsolete, or changes of practices that we want to capture as well. And we need to consider the areas to include in this document. Some things we didn't really put much emphasis on in 8504. So there are things I'll come on to in a moment that have come to more precedence, that's maybe not the right word, since then, and we should maybe include those. Maybe there's some things we should deprecate as well, for whatever that word means. Anyway, your input is very important to help steer us, the authors, as editors of this document. Next slide. A big quick plug here for those of you, I guess most people are aware of Brian's, book 6, not 6 book, project helps here. If you look at the link there, you'll see part of this online book that's captured in Git is a list of all the RFCs, and you can deduce from that the ones that are new since 8504. So there's 38 standards track RFCs related to V6, 14 informational, 1 BCP, and 4 experimental. So that's 50 plus documents to look through. That's a rough approximation. There may be some that actually have RFCs lower than 8504 that were published as we were finalizing 8504. So that gives you an idea of the scope of 50 documents to look through. Plus, potentially, there's current drafts, which, as I said, may be published as we progress 8504 BIS. If you are aware also of any RFCs that are not in that list on book 6, please do say so. I'm sure Brian would welcome some edits to add those if something has been missed. And this final thing on this slide, we did previously discuss this idea of a kind of a living RFC for node requirements, or a living document for it, but that hasn't happened yet. Maybe that will happen with this revision, but we can come to that later. Next and last slide, I think. Yeah, so here's some, last slide, some examples of things that we might change, things we might add. So there's been some documents on v6 extension header processing and limits, and on hop-by-hop option processing. I'm not sure, I think at least one of those is now an RFC or almost an RFC, and the others are quite advanced. So those could be worked in. There's the whole stub networking area, as we heard about a little bit today, in the IoT-related requirements. That's not really captured in the current document, that area. Segment routing, the IOM stuff, Slack and Frash renumbering. That's almost out as an RFC. That's something that we may wish to include. Security side of things, and some things that are currently drafts that are look very promising as things that we might want to work in. So the PD per device stroke client and the v6 mostly model. And there's things we may also wish to, those are just examples. And there are things we may wish to remove. So can we finally just remove mobile IPv6? Can we remove send? Can we remove other things? Interesting to hear. And the final one that's, yeah, I think I discussed this with Tim. So this is an IPv6 node requirement, but it kind of in a way, we would like to say node should implement DHCP v4 option 108, but I'm not sure we can put that in this document. Maybe we can have it sort of as a little sort of appendix of things you should do if you've got v4 to help IPv6 or something. And I think that's it. I think the last slide is just comments. So I think the first question is, does the room want us to progress with this? And then the second question is, what do you think of what we've said here?
Jen Linkova, no hats on. Yeah, so thank you very much. I personally think it's a good idea. I definitely think I have a few ideas what should be added, like prefix for support on host is highly desirable currently. So we can finally get rid of RFC 7050 as it is and improve security reliability. I was actually going to suggest this morning that we might think about CLAT support on hosts. On the other hand, if you say should, what about like 10 years past when we don't need this stuff maybe? I don't know, we can just maybe just
but then we'll have
again.
there'll be another rev by then.
Yeah. For option 108, I personally do not think we need it because it has nothing to do with v6. It's your v4 stack, right? Yeah, host, but it's useful, to move to v6 mostly, but for example, if host has CLAT support.
So I think what I can also draw from what you're saying there, I think in 2019, there was quite a strong feeling if you should deploy dual stack in enterprise, that's the way to go. And I think now when I speak to people at some of the more forward-thinking universities who are already dual stack, they want to remove the v4. So all the things you said are about removing v4 to go v6 towards v6 only. So I think that's maybe another theme of the update, but it's something that we need to make sure is well included.
Lorenzo Galili, DHCP4 option 108 is an IPv6 node requirement. If a device supports IPv4, then it should, if an IPv6 node supports IPv4, then it should support this, right? So if it doesn't have to support IPv4, in which case it doesn't have to.
I think it might be the only thing we put in the document that is sort of an IPv4 requirement, though.
That's okay. It's a requirement for IPv6 nodes. It's not a requirement for IPv6 stacks running on nodes.
Yeah. No, I agree. It's just something we thought we should flag, for the want of another word, just to check everyone's okay with that.
Yeah, I'm not sure how. Do folks actually read all of these documents? Do the folks read these documents in their entirety? There's sort of a lot of stuff there. I feel that maybe it would be more useful to have these, it's kind of like operational recipes. If you're building this, then you should have these options, like something like more like 7084, but I don't really know much.
Yeah, it's become with each of obviously this is the third revision, and it's become more, I suppose, bloated is a word for it. How to get some focus on it for someone that's implementing for a specific area, if you like, a type of use case, a type of device. Eric, what was it, Tim next?
I think it's me next. Tim Winters, QA Cafe. So a couple things I just wanted to point out. One about the header extension text. This document was sort of unique in that we wrote I had forgotten about this. We wrote a bunch of text about header chain limits that obviously we're going to remove, hopefully, and point to the newer drafts.
But I think that was written by the authors of these.
They did. Tom did send me that text that I stuck in there. So there's good news there that we're going to update those, which I think to make sense. For the V4 option, I kind of, sounds like people are cool with it, so I think we should go with it. I also think, yeah, we probably should add a section for V6 only and write some words about CCLATs and other things that people should think about if they want to try to run a V6.
Yeah,
node.
Pref 64 and stuff.
Yeah, do all that stuff.
Yep.
So Eric Vink, yes, please go on with this work for sure. Regarding the IPv4, I mean, the document is about requirement from an IPv6 node, not IPv6 requirement for an IPv6 node. So you are all set. And even if we kind of stretch somehow the process, go for it, right? That makes sense. Something which is missing that you want to add is Lorenzo and Jen's draft, which is mostly just approved in DHC, restoring the self-generated addresses because that's important for operations.
Sorry, that does what?
The self-restoration by
oh, right,
DHC,
the self-registration. Yeah.
Jen go again as an individual. I actually forgot what I was going to say.
So I can't see who's next from here, so it must be.
It's all right. It's Tom Hill, BT. I think, you know, it's great to be updating this. These things need to be updated on a regular basis anyway. Things are changing so often. And actually it came up in conversation internally at work recently, so quite useful. I would say that, you know, on the remove column, can't see anything particularly wrong with suggesting that we get rid of those. Adding all seems pretty good. I would think segment routing over IPv6 is probably crossing the streams a little bit too much. I'm not sure that's something we need to start thinking about every single device supporting. And it certainly has a different aim versus a lot of the other things on that list. So, but yeah, good work. And if I can help support it, I shall.
Thanks, Tom.
I suddenly remember what I was going to say. We had an interesting discussion in the lobby today about like what the host should, the operating system should do in terms of implementing APIs which might render CLAT either unnecessary or not used too much, right? I don't know if we would be capable of formalize this, but maybe we need to think about, is there anything to say? I heard that TAP's been doing something in that area, which might be helpful. It's just an idea which I just,
Okay, yeah, that's an interesting suggestion, yeah. Okay.
Kayan?
Yes, can you hear me?
Yes.
Okay. Yeah, I was just wondering, would like any updates related to, let's say, IPv4 as a service or transition technologies, would that be something that would be a good add to this, or? Can you hear me?
At all, sorry.
I think he asked transition technologies included in this.
Yeah, do you think that would be like IPv4 as a service and some of that stuff, I guess? CLAT and 464XLAT and all of that, I guess, updates.
Yeah, I mean, we touched on this a little bit earlier. I think we have to be careful about the text we put here because we obviously want to promote V6 only, and these things are V4 as a service. But yeah, what I'm hearing from the group is that maybe we should make an attempt at this and see. We'll add some text and see what people do with it. I think we'll add a new section for V4 as a service type situation.
Right.
Obviously, this is general nodes, right? We're not going to go into all the softwire and MAP-T and DS Lite. That lives in a very different place, far, far away. This is just for the node requirements.
Gotcha.
So, yeah, I think we can do something there.
Yeah, I think.
And I noticed you had the IPv6 segment routing in there as well. Is that, I mean, since that's not something that's generally on any node, I mean, you usually like service provider nodes, and maybe like if you have a heterogeneous network and you have appliances, which is probably rare, but you know, it's not a general node requirement that you would have IPv6 segment routing. So I'm not sure. Would that be something that still would be applicable here, or?
Sorry, again, I had trouble hearing that.
I caught most of that. So yeah, I think for segment routing, we're going to have to be, obviously, we do not want to apply that to all nodes for sure. And we don't want to even probably apply it to all routers. So yeah, we'll add some text in there, just kind of pointing people in the general direction is what we've done in the past for bigger technologies like that. Like, hey, if you're looking for this and you're in this document, please go over here and go read. I don't think we have any illusions of requiring every node to be looking at segment routing packets.
Right. Yep, agreed. Thanks.
Okay, so yeah, that list under add ? Was partly, well, mainly drawn from looking through the list of the 50 or so new RFCs, and there are a number of them that refer to various aspects of segment routing, hence it's in there. Okay.
All right, thank you.
All right, thanks, Bob.
Well, so the next session is our time allowed section, and for once in a long time, we actually have time. So, so the first, I think Tal is the first speaker, and I will encourage all of the time allowed speakers to stick to their 5 minutes so everyone can get a chance to talk. Go ahead.
Great, thanks. Can you hear me?
Yes, we can.
Okay, thanks. So this is a short update about ICMPv6 loopback. Next slide, please. So just an update about what this draft defines. Generally speaking, we're talking about the loopback, which defines two new ICMPv6 types. It's very similar to ICMP echo, except that when we send the loopback request, that's the blue packet at the top, the loopback reply includes the original loopback request as part of the payload in the reply. So what do we get from this? We get the IPv6 header of the original request, as well as the extension headers, the options, and so on. And there are a lot of different use cases that can benefit from this. For example, IOEM, path tracing, IFA, anything related to measurement. SRH reflection. You can basically get the SRH from the original forward direction. And there are a lot of other use cases which I'm not going to mention. Next slide, please. So one thing to point out is that we have an up and running demo, and it's available on GitHub. And basically what this demo does is kind of an IOM ping. It's similar to the ping utility that we're all familiar with, but it collects per hop information using IOM. And using the loopback message, we get that information back to the sender, so we can display it on the screen, and that's what we see here. And I should mention that the implementation is very simple, because basically loopback is actually very similar to traceroute, to the way traceroute works. So that's just a side note. In general, the current version of the draft accommodates, we believe it accommodates the main comments we received on the mailing list. And there is another draft, which is going to be discussed in a few minutes, which has a very similar goal. And we believe that there should be some discussion to try to merge these two drafts. So that's one of the next steps. And obviously, we'd like to hear from the working group any feedback, as well as feedback whether it should be adopted by the working group.
Thank you. So I think Ron is next.
Okay, this is a very similar draft, Loopback 6, and it's a utility for detecting IPv6 extension header changes. Next slide. It works very much like ping. It sends an ICMP extended echo request message, that's type 160, not 128, to a probe node, like any IPv6 message. It's encapsulated in an IPv6 header, and the IPv6 header may carry extension headers. Next slide. The probe node receives the probe. It returns an ICMP extended echo response. The extended echo response contains an extension header, a la RFC 4884. The new extension header contains, the old extension header contains some new objects, and those objects reflect what the HPH options, routing, and destination options looked like when they arrived at the probe node. That gives the probing node some idea of how those options changed en route. Why would you want to do that? Well, there are some applications that do things like, they have mutable extension headers. They change the extension header in the path. Sometimes they do things like collect OAM information at each node along the path. So the probing node might want to see what it collected. And again, I think Tal has it right. The last two drafts need to be merged. And that's it.
Thank you, Ron. I actually, thanks for the last comment, because I was going to jump into queue and ask the question about, do you guys want to talk to each other and maybe merge those drafts here? So I guess we'll leave it to you and we'll see some.
Tal is a co-author on both, so yes, it needs to be merged.
David Lamparter. Both of the drafts discuss amplification in their security consideration section. Can I suggest that whatever the result of the merge is, that you always just have the reply be of the same size as the request and specify that content is just truncated to the same?
We don't quite have that, but we do have a limitation of 1280 bytes. So if there is some amplification, it won't be too bad.
I think it is much simpler and also completely eliminates the security issue if you just require that the reply is the same size as the request and say that the request by the host should just be large enough to accommodate all the information, i.e. you could just suggest that the request should always be 1280.
Ooh, good idea.
So just in generally in this section, clarifying questions that are quick are good, but discussion should be on the list. Thank you. So, thank you, Ron.
Thanks.
Fred.
Okay, so I'd like to talk about IPv6 addresses for ad hoc networks. Next chart. So when two or more IPv6 nodes come together within an ad hoc network operating region, they must be able to assign unique addresses, discover multi-hop routes, and exchange IPv6 packets with peers even when there's no internetworking infrastructure present. So in the diagram here, you see an example ad hoc network. The neighbor relationships appear as point-to-point links underneath an ad hoc interface. So the ad hoc interface is essentially connecting to a multi-link. So in this diagram, for example, you have node 2 has neighbors, node 1, node 3, and node 4. But node 1 only sees node 2 and node 5 as neighbors. So multi-hop forwarding might be necessary for node 1 to be able to communicate with nodes 3 and 4. This applies also to any local network type, not just the mobile ad hoc networks. But if we look at these interfaces on these routers, what addresses can we add to those interfaces? RFC 5889 says that GUAs and UALAs should be used. But the problem with that is that coordinated provisioning in isolated networks is not always possible because there's not always a DHCPv6 server or a Slack router sending RAs. And RFC 5889 also explains why link local addresses have limited use, as do the ad hoc network interface multi-link nature. So what we need is a new type of addresses, and we're calling those multi-link local addresses, or MLAs. Next chart. So why do we need MLAs? They are going to have extremely high assurance of uniqueness, so they won't conflict with other nodes that are in the same operating region. They're self-generated or self-asserted by each node, so we don't need to have infrastructure that assigns the addresses. The uniqueness persists across network partitions and merges, and it supports multi-hop forwarding at the adaptation layer, at a layer below IP. They're greater scope than linked local addresses and can be applied to multiple interfaces. So nodes assign an MLA to an ad hoc interface as /128 using optimistic assignment procedures. Nodes may also assign a GUA to overlay multi-network interface when an internet gateway is present. So in this figure, you see that each one of these nodes is assigned an MLA, these addresses starting with the FEE prefix. And in the blue address, we have a globally unique address that's assigned not to the MAN interface, the ad hoc interface, but assigned to an Omni interface. And that's to allow internet access when we have connectivity to the internet. The types of MLAs that are being proposed, type 1 is to repurpose the prefix FEC to 0::/10. There's an example address there that you see. Type 2 is to use the prefix 2001:20/28, and that's from RFC 7343, which is the ORCID format, also used by the HIP-HIT. And then type 3 is to use the prefix 2001:30:/28, which is used by the hierarchical host identifier tag, and that's documented in RFC 9374. So then the next steps is to decide whether we can have this as a working group item. That's all I have.
Thank you, Fred. So I guess we'll be looking for the comments for the draft on the list. I don't know how many people read the draft, but I encourage people to do that. Thank you. Okay, hold on. Yes.
Shall I start?
Yes, please, sorry.
Okay, so if you're allergic to administration, you should look away now. Next, please. So the problem we're talking about here is that the management of the IPv6 address space, all 128 bits of it, was delegated to IANA by RFC 1881, which was an IAB informational document, and it didn't define an IANA policy for what to do to manage this address space. Actually, I think at that time there were no defined IANA policies anyway. That was a long time ago. So IANA.org shows a policy, and the policy is IESG approval, and that is for the whole reserved IPv6 address space. Okay, everything, 2000::3 is being delegated, but 4000::3 is IESG approval, and all the rest of it. According to BCP 26, which is the IANA considerations document, there is no requirement that a request under the policy IESG approval, there is no requirement that the request be documented in an RFC, and community review is possible under IESG approval, but it's not even required. So basically, these rules say that the IANA and the IESG between them can delegate the entire IPv6 address space without asking anybody. And a few of us noticed this, and we think it's inappropriate. Next, please. So the proposal is a BCP, which is the draft, requests IANA to update the registration procedures section of the address space registry to show the policy as IETF review. That's intentionally not standard track document required, but it does require a document, and it does require a community discussion before the IESG can approve something that's under IETF review. So that basically fixes the bug that the community isn't involved in allocating address space. For example, the kind of allocation that was just discussed in the previous presentation, technically speaking, doesn't need community review or an RFC. The housekeeping that's also required is to clarify that that RFC is in the IEB publication stream, because the RFC index for some reason classifies it as an unknown stream or something like that. And some of the registries that Diana maintains in this area have quite confusing names. There's inconsistencies between the naming of several of the registries. But those are minor details. The main point is simply to say, let's make sure that if we allocate address space, there is an actual consensus process before we do it, and some documentation. And that's it.
Okay, thank you, Brian. So again, please read the draft if you haven't done it yet and comment on the list.
Hello, can everyone hear me?
Yes, we can.
Okay. So hi, my name is Gyan Mishra, and I'm presenting this draft. Actually, I've had a slight typo I just noticed at the title. So it's 6-man variable IID problem. Sorry, this is a typo actually on the header. So this is 6-man and the variable IID solution is what this deck is describing. So this draft is about variable IID. So last year, at the end of last year, there was a discussion thread on 6-man related to a variable ID, and I believe Brian Carpenter, he was in the discussion as well, and then there was a whole bunch of folks. So I had brought this up a few years ago about variable ID, variable slack, kind of the 64-bit boundary discussion, but I think at the time there was a lot of resistance, but I think a big piece of that was one is having a concrete, and I actually mentioned, even though I had the confusion here with the title, but the problem statement is really the one big piece of it, and I'll be discussing that on V6 Ops later this week. But then there's also the solution piece. So when you think about the solution, one issue that has been there when we had this discussion in the past is, well, Slack is used everywhere, and we don't want to break anything that's existing. So the backward compatibility and having a concrete solution is really key to really making this really go anywhere and kind of getting interest. So it did appear, I think, from that discussion thread at the end of last year, it seemed like this seemed like a good point to maybe try to introduce this and possibly making a slight modification to the standard for Slack, that fixed boundary, and changing that fixed boundary slightly. So next slide. Next slide. So one of the issues that had come up in the past when we had brought up this concept of having a variable Slack, so not having the 64-bit, but actually making it so you can have a variable length mask and you're not stuck at /64, is the race to the bottom. So what we would do is we would only allow, and a part of this is just an additional 16 bits would be short. We would shorten the IID. So the interface ID would be from 64 bits, it would go to 48 bits, and the prefix length would be /80. So that would eliminate the concerns, which there was a lot of concerns about the race to the bottom. So we're trying to kind of nip that one, that we don't have the race to the bottom. And then I think the second big issue that had come up in the past was backward compatibility. There is a number of devices around the world that are using Slack, and we don't want to break anything. So Brian Carpenter, he had come up with a really nifty scheme, an idea which it makes sense. And this is basically the idea that he had come up with, which I think it seems like a very good idea, but basically having the network. So when it would be very similar to like if you're doing like a router advertisement and you're doing IPv6 and you're a route, you have your M and O bits options that you're sending in the router advertisement, you're setting the M bit or O bit for DHCPv6. So here we're using the PIO options. We're using the 32-bit reserve field, which is not used today, but we're using 6 bits of that reserve field to send the IID length. So, and that basically it's 6 bits in that 32-bit field that would be carved out, that it would actually specify the actual length, and that would be signaled from the router to the host. So if there's any host that does not support it, they would ignore that reserve 2 field, and that would kind of be the default behavior. That's in RFC 4862 specifies that if the PIO is sent and so any device that's what we would call unmodified routers, so any router that's unmodified that doesn't support it, legacy, that's not upgraded to support, they would actually the reserve field, even though it's set, it would actually be ignored by the host that receives it. For hosts that do support it, they would actually be able to process that. They would see the signaled 6 bits of the IED length, and then they would see let's say if it's I gave an example here. So let's say you signal /69, and then it's the IED length is 59 bits. So that would be signaled in the reserve field. The reserve 2 field would have that 59 bit set in the ID. The host would actually would process that and build the 128 bit address. So that would allow any devices that support would work. At the bottom here, I have a little chart is kind of with operational consideration. So let's say if you have unmodified hosts and modified routers, there would be no change. Everybody would use 64-bit, of course. And then even if you have modified hosts and unmodified routers, since it's signaled by the router, no change. So everything is 64-bit. And then if you have modified routers that are supporting it, but then there are no hosts there, of course, there still would be no change. So the only time there would be a change is if there's modified hosts and modified routers. So you have hosts that support it. You have the router actually supports sending that IED, the 6-bit length that's encoded into the reserve 2 field. And now you would actually be able to build that longer prefix with a shorter IED, down to 48 bits. As far as
Kian,
yes,
so your
yes.
time is up.
Okay.
But I would like to, I believe you were talking about your problem statement that goes along with this in V6
Yes.
Ops. So
Yes.
I would encourage anyone who's interested to come listen to that in V6 Ops. So thank you.
Thank you. Thank you, Bob.
So I think we are done. So thank you everyone for coming. We hope to see you all in Dublin whenever that is. It'll probably be a little colder and wetter, but should be nice. So thank you very much.
We'll fight. It's better. Can I get a big one?